Okay, so we're in section 1 of chapter 3. We're going to do 7 through 11, 7 through 10. So these are basically looking at, the parent function, the new parent function that we know, and how do you get transformations with the exponential function? And it's very similar to what we've seen before. So what we need to do is kind of draw a picture of the parent function. And the parent function is y equals e to the x. So e to the 0 goes through there, so at x equals 0, y equals 1, because e to the 0 is 1. And then it increases like this pretty quickly. E to the first power is 2.7818. That's the value of e. And e to the minus 1 is 1 over that, so 1 over 2.78, which is going to be about a third. And it goes down like that. Okay, so that's our parent function. So we just have to match the graphs with the functions. Well, the first one is actually the parent function, and in this case it's not e to the x, that's my fault. It's 2 to the x. So how does that affect the parent function? Not a whole lot. 2 to the 0 power is still 1. 2 to the first power is 2. 2 to the second power is 4. 2 to the third power is 8. And then you have 1 over, you get 1/2, 1/4, 1/8. And so it looks very similar. It looks like that. So those are the, that's the parent function. So the first one, 7, is just f of x equals 2 to the x. So if we look at the 4 pictures, the key thing to look for here is this intersection, the y-intercept, which is 1. And if you look at all those, you see that the only one that has this shape, which is small towards negative infinity and large towards positive infinity, is D. So D is 7. Then you have 8, which is f of x equals 2 to the x plus 1. So all you're doing there is you're just shifting everything up 1 unit. So we should have a y-intercept of 2, and we should also have it increasing in that manner. So the only one that looks like that is C. The B kind of looks like it's smushed on the other direction. So let's see what we have left here. Number 9 is f of x equals 2 to the minus x. So when you have the negative sign associated with the argument of whatever the parent function is, then that is a reflection across the y-axis. If it was negative 2 to the x, then it would reflect across the x-axis. So the only one that's reflected across the x-axis, I mean the y-axis, which would look something like this, is A. And it still crosses, 2 to the negative 0 power is still 2 to the 0, so it should still intersect here. And then the final one just by process of elimination, but even if it wasn't by process of elimination, what that is a translation in the x direction. So it's going to be moved 2 units in the x direction, which means that now instead of intersecting here, it's going to intersect there. So when x equals 2, you get 2 to the 0. 2 minus 2 is 0. 2 to the 0 is 1. And so what happens is it just gets shifted. And that is B, which was the only one left anyway. Okay, 11. So the next 7 or 8 problems. We've got 3 in that area, 4 in that area. It says use the graph of f to determine the transformation that yields the graph of g. Okay, so let's see what that means. So you've got f of x equals 3 to the x, and then you have g of x. And I think they're only looking for words here. They're not looking for, they're looking for how does this compare relative to that. And if you look back to the previous problem 10, you can see that the x translation is associated with the, if there's anything added or subtracted. So this would be shift f of x 4 units to the right, because the same rules apply in the exponential functions as they do in any other function. So when you have x minus something, it's x minus h. H is being how much you shift, positive or negative. So h in this case is 4, positive 4. So it goes to the right 4 units. Okay, 14. We have f of x equals 10 to the x, and g of x is 10 to the negative x plus 3. So just like we had to do in previous cases, when you have a negative sign in front of the x, but you have an additional term, you factor out the negative sign. So you're going to have negative the quantity x minus 3. So this negative means you reflect across the y-axis, and this one means you shift it to the right 3 units. So that should have been shift, not swift. So what we do is shift, actually first we do the reflection. So reflect across y-axis, shift right 3. And I think what we'll do is we'll plot these just to prove that I'm actually doing them correct. So let me open up my graphing program. So the first 2 functions were 3 to the x and 3 to the, and notice I use parentheses to make sure that it knows to include the whole thing in the exponent. So we do that. And so this is the parent function, and you can see it's shifted 4 units to the right. That's all. Okay, so that was the first one. That was number 11. Number 14 is 10 to the x and 10 to the negative x plus 3. Okay, so we'll graph those 2. So what we have is, the first thing that we do, I should put an intermediate point in here. We'll do 10 to the negative x. And what you'll see with that is it'll reflect across the y-axis. So the blue curve is the red curve reflected across the y-axis. And then what you do is you shift it 3 units to the right. So you shift the blue curve to the right. Okay, so that one's correct also. Okay, 15 is f of x equals 3/5 to the x, and g of x equals negative 3/5 to the x plus 4. So we do our reflection first. So the reflection, because the negative sign is here instead of in there, we're going to reflect across the x-axis. So that does that. And then we're going to shift it 4 units to the left, because you'd have x minus h. Well, then h would have to be -4. You'd have negative and negative. Okay, so we're going to plot those, but we'll do the reflection, and then we'll do the whole thing. And let's see what happens first when you have a fraction instead of a whole number. I mean, instead of a larger number larger than 1. So we have 3/5 to the x power. Let's just look at that. See. Okay. So we're comparing that. Let's just compare that with, well, let's say a positive number, 2 to the x. Not a positive number, but a number greater than 1. So you can see having a fraction is like changing like you're reflecting it across the x-axis. So let's just actually do, instead of 2, let's do 5/3 instead of 3/5. Okay. Now if I do negative, if I put a negative in the exponent, so if I do 5/3 to the negative x, they should be the same thing, because then they'd be reflected. So you can see that they're the same curve. So I might go back and look at that in a second, but that's not what we're worried about here. Okay. The first thing we're going to do is we're going to put a negative sign out in front. So we'll have -5 3/5 to the x power. And that should reflect it across the y-axis, the x-axis, which it does. You can see there. So this is the original function. This is the reflection. And then the final thing we're going to do is we're going to have the negative sign, 3/5 to the x plus 4. And gotta get my parentheses the correct direction. So that should shift it to the left 4 units. So this one should move to the left. So we should have this point should be moved to there. So let's see if that's what happens. And it does. So the green curve is the blue curve shifted to the left 2 units. Okay, so that's correct. But let's answer the question. We saw that if you looked at (3/5 to the x was the same as 5/3 to the minus x. And the reason is, so we took the reciprocal and then we changed the sign here from positive to negative. We saw those were the same function. And why is that? Well, if you had 5 to the minus x divided by 3 to the minus x, then you can move this to the numerator and that to the denominator. You have 3/5 to the x over 3 to the x, 5 to the x. And then because you have the same exponents, you can do 3/5 to the x. So that's why they were the same function. That's why they ended up being the same thing. So yeah, having a number here between 0 and 1 looks the same as a number greater than 1 raised to the negative exponent. Okay, and then the last one here is this group is 18. So what do we have? We have f of x equals 3.6 to the x, and then we have g of x is equal to negative 3.6 to the negative x plus 8. So you got a negative here, which will make it reflect across the x-axis. You had a negative here, which will cause it to reflect across the y-axis. And this one's going to shift it to the upward. Yeah, okay. So we're going to say reflect across x-axis. Reflect across y-axis and shift up 8 units. So, what does that mean before we plot this thing? So here would be the parent function would look something like that. It's going to go through 1. It's going to go from small close to 0, then go that way. So the first one, when you take this negative sign into account, that reflects you across here. So it goes like that. Then this negative sign reflects it across the y-axis. And then the final thing is going to shift this thing up 8 units to something like that. So that's what it should look like. So again, we're going to plot this thing. And the exponent is, the base is greater than 1, so it's going to have the form we talked about earlier. So let's just do 3.6 to the x. We'll do negative 3.6 to the x. We'll do negative 3.6 to the negative x. And we'll do negative 3.6 to the negative x plus 8. We may have to change the scale here a little bit. Let's go to a y max of, let's say, 10. And see what we got here. Okay, so here's the parent function. 3.6 to the x. This is negative 3.6 to the x. That reflects across the x-axis. Then you have negative 3.6 to the negative x. That's the green curve. So that is, the green curve is the blue curve rotated across the y-axis, and then finally we shift it up 8 units. So we take the green curve and shift it up 8 units, and that's the final answer. So I always want to do your reflections first. Doesn't matter which reflection you do first, but you got to do both reflections if there are 2 reflections. Okay, next one is 52. So these are word problems. A deposit of $5,000 is made in a trust fund that pays 7.5% interest compounded continuously. It is specified that the balance will be given to the college from which the donor graduated after the money has earned interest for 50 years. How much will the college receive? Okay. So this is where we haven't done it yet, but if you go back to page 204, it says the amount in a savings account, which is interest is compounded continuously, is P, the principal, that's the initial amount, times R, which is the interest rate, in decimal form times the number of years that occur. So for our particular case, the principal is $5,000. The interest rate is 7.5%, but it's 0.075 is the decimal equivalent. The T is 50 years. So we plug those in. So A is equal to 5,000 times E to the 0.075 times 50. So get the calculator out. 5,000 times E to the 0.075 times 50. And I get $212,600 approximately. Okay, 53. If the annual rate of inflation averages 4.4% over the next 10 years, the approximate cost of goods and services during any year in the decade will be modeled by. Okay, so the equation is this. This is really the same as the equation, first equation, compound. It's like compound interest, except you're compounding inflation. Estimate the price of oil change for your car. It's presently $23.95. Estimate the price 10 years from now. So P is the present value, which is the $23. T is 10. So we get 23.95 times 1.04 to the 10th power. And I get $35.45. Now luckily inflation has been closer to 1 to 2% over the last 10 or 15 years. But if inflation is high, then your buying power, if you don't put your money into some account that's going to gain some interest, then you're going to you have to pay more later, and you're not going to have more later. That's one of the things that retirees have to take into consideration in determining whether they have enough money left. If they'll have enough money. And the last one is 66, which is, think about exercises. Okay. Use properties of exponents to determine which functions, if any, are the same. Okay. So we kind of did that earlier. So we've got f of x equals 5 to the minus x plus 3. G of x equals 5 to the 3 minus x, and h of x is equal to negative 5 to the x minus 3. So the question is, any of those the same? Well, this is definitely not going to be the same because this one's shifted 3 units in the y direction. If I factored out the negative sign, I'd have negative times x minus 3. So these are both shifted. The question is negative 5 to something the same as 5 to the negative something? And the answer would be no. So this one's a reflection across the y-axis, and this is a reflection across the x-axis. So even though they're shifted the same, they're going to be pointing in different directions, I think. Let's just try it out. Let's think about this. So 5 to the x is going to be something like that. Okay. Now they both shift the same, so we really don't have to worry about it. We just have to think about this reflection. So if we take 5 to the negative x, what's going to happen is that's going to look like this. And if we do negative 5 to the x, then it's going to look something like that. And obviously those are not the same. And so this is the last problem. I'm going to look the answer up into that for that one. So this is 3.1. 3.1, 66, none. Okay, so yeah, none are equal. But we did look at an earlier case where they were equal to each other. So let's go back and look at that case. Yeah, it was this one. I think we had, or maybe that was the one. Yeah, we looked at, it wasn't exactly this one, but it was similar. We took the reciprocal and then we had a negative exponent or something like that.